Newton's first law of motion states that an object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. Safety first! I was sitting in a car moving at 16 kilometers per hour. Because of inertia, my body stayed in motion with the car even when the brakes were applied. The seatbelt restricted my motion, keeping me from flying through the front of the car.
Newton's second law explains how the velocity of an object changes when it's subjected to an external force. To demonstrate Newton's second law, we punted a football. Davis held the football at rest, which had an original velocity of 0 kilometers per second. I then applied an external force as a kick with a greater velocity to the ball. Because my kick had a greater mass and velocity, the resting ball was then projected through the air with a new velocity.
As Lauren was getting a drink, I, having a greater mass than her, knocked into her, sending her straight into the mats, safely executing a fall. And this was a great demonstration of Newton's second law.
Newton's third law states that for every action in nature, there is an equal and opposite reaction. Because Newton's third law requires two velocities coming into collision, Davis and I each jumped into each other. The force of each our bodies against the ball created an equal and opposite reaction on the other person. Davis fell with the amount of force I jumped with, and I fell with the amount of force Davis jumped with. The ball was present for safety reasons.
I modeled Newton's third law of every action there's an equal and opposite reaction by jumping on the Bosu ball and having my force acted upon by gravity and the force exerted by the Bosu ball pushing me upwards and back down, and then successfully cushioned my fall with the squishy mat so I don't hurt my ankles.